Hey guys, this is Taylor here, and today we are solving the third problem of Biweekly Contest 164. So let's get started. So question name is Twisted Mirror Path Count. Okay, so let's read the question. Given an m cross n binary grid, where grid of ij equal to 0 represent an empty cell and grid of ij equal to 1 represent a mirror. Okay, we will see what is empty cell and what is mirror. A robot starts at top left corner of grid 00 and wants to reach the bottom right corner m-1 and n-1. Okay, m-1 and n-1. It can move only right or down. Okay, so it can move right or down. If the robot attempts to move into a mirror cell, it is reflected before entering that cell. We will see what does that mean. If it tries to move right into mirror, it is turned down and move into the cell directly below the mirror. If it tries to move down into the mirror, it turns right and move into the cell directly to the right of the mirror. Okay, we will understand what this means. If the reflection would cause the robot to move outside the grid boundaries, the path is considered invalid and should not be counted. Okay, return the number of unique valid paths 0 to m-1 n-1. Since the answer can be large, we need to return it modulo this number. If reflection moves the robot into a mirror cell, the robot is immediately reflected again based on the direction it is used to enter the mirror. If it entered while not, okay, well, like I am not reading this whole thing for you. So just to explain you what the question is saying, let me draw a metric. Okay, so here is my first test case of the question. What I need to do. So basically question says that I need to count paths from this index 0, 0 to the index n-1, m-1 to the last index of the array. So paths, like if we ignore this ones for now, for example, so my paths can be like this. This is the first path. This is the second path. This is the third path. Okay, and so on, so on. I can have so many paths, and the only condition is, okay, I can either move right or down. Okay, so two possible moves are right move or down move. I can't move to left or up. Okay, because I want to reach the last index. So I think if we ignore this mirror thing and if we ignore this ones, this question is clear. Okay, we need to move to right or down and we need to count how many paths. So there can be a lot of paths. One path can be this, 1, 2, 3, 4, like this and so on, so on. There can be a lot of paths. I'm not counting all of them. So how like what is this mirror stuff? Let's understand this. So let's say I am here and I am moving to the right. Okay, this is mirror. And in this mirror, how I am entering? I'm entering through right direction. So according to question, this says that I will be directly jumping to the down. If I'm entering from the right direction, I would be directly jumping to the down. And for example, let's say I am here and I am moving down, for example. So I'm how I am going inside mirror, I'm going through down. I'm going through down. So I will be I will be immediately get jump to the right direction. So I hope question is clear now. So if we enter mirror from right, so that means jump to down, immediately jump to down, no matter. So let's say if let's say for example I am having a 1 here and I am moving like this, no matter from where I am coming, where I can come from 1, I can come from 0, that doesn't matter. How I'm coming from right or down, that matters. If this is, let's say if this is a 1 and I am coming from right, no matter what is this, I will be jumping towards down. Okay, immediately I will be jumping to down. Now this is the out of bound case, so in this case, this path will be invalid. So I will not be counting this path. This is the question. And let me complete this. So entering from right to jump to down and enter from left. Oh, sorry. Enter mirror from down. So that means I will be jump to right immediately. no matter whether it's out of bound or what. As soon as I reach the mirror, I will be directly get jump. Okay. So I hope question is clear now. Now let's see some of the valid paths. So I think I will start from here. I can go right direction, and as soon as I go the right direction, this is mirror. So immediately I will get jump here. Super. Now from this, I can go right, I can go down. Why? Because this is zero. This is a normal cell. I can move to the either of direction. So let me move both. Okay. First, let me try this. I'm coming from right in the mirror. What will be the case? I will be directly get jump to the last index. As soon as I reach this, I can increment my counter to 1. Super. Now let me try the down path as well. I am 0. I can move down as well, right as well. Let me move both. If I move down, I will get an invalid path. Let me move right. Okay. I again reached the final destination. Let me increase my counter. Super. Let me try. Okay. For now, let me undo this thing so that we can understand other paths as well. Superb. And my count is 2 for now. Now this path is done. Now I'm exploring this path. Okay. From this, I can either move to right, either I can move to down. Now from this one, you can observe that I haven't moved here. I haven't moved here. As soon as I reach from the right, I can only move to the down. Okay. Super. So this path is done from this right direction. Now I will be moving to right. Now this is a 0. I can either move right, I can either move down. Let me try both. Let me try moving right first. Okay, from this is again 0. I can move either here, I can move either here. Let me try both. So let's say I'm moving right. I am here. As soon as this is mirror, like as soon as it is coming from right, I will be moving to down. I'm moving to down. I have reached the final destination. Let me increment the counter. Super. Now this path is done. Now let me try this path. So I came to 0. Now I can move to right. I can move to 0. Down, I mean. So final destination is I can increment my counter. Super. This path is also done. So okay. So if both of paths done, this path I can also say done. Let me try this path. Okay. So I am here. I am coming to down in the mirror. What I can do, I will immediately move to the right, right? Super. Now this is 0 and I can either try this path. So this path, I think I can reach and I can increment my counter to 5. We can cross verify this thing. So answer is 5. Super. So how we can solve this problem? So first of all, if you have solved the problem, if you are good in DP, if you have solved similar problems, so there is one similar problem. Like if we have some graph like this or matrix like this, we need to count how many ways, how many paths we have to reach from here to here, and we have some obstacles here. So let's say one is here in this case, one is mirror. But in some other DP questions, one is obstacle. So we can't move from there. So we can avoid this path and we can move either of the places like this, like this, like this, like this, like this, like this. Okay. This is one typical traditional DP problem. So this is some kind of similar problem. So if you have solved this one, this problem will be easy for you. And if you haven't solved this problem, like after solving this, try this one as well. So you will get a practice around okay, what is happening. So, super. Let's discuss the approach. So, let's talk about the intuition of this problem. And if you are familiar with DP, you can definitely pause the intuition and you can try to implement this question by yourself. Then you can later come and check. If you are not familiar with DP and recursion, so I will recommend you to directly move to the approach section and where we will discuss in detail how to solve this kind of problems. So let's get started with the intuition. So intuition is, let's say we have this array like this, or maybe we can discuss here as well. So in this array, we have 0 here, we have 1 here. So if let's say I am moving like this, and if my current index, if my current value is 1, for one thing to note is the first index, the grade of 0, 0 and grade of last index will be always 0. Okay. So that edge case we don't need to handle exclusively. So let's say if I am on this part, if I am on this part, I will be getting something like a 1. Okay, so now let's say okay, I am moving like this and like this, and for now I am moving like this here. So you know that you need to keep tracking the third index in your DP, which is whether you are moving from right or you are moving from down. Like if you are entering from the right side, you can make it R. If you are entering from the up side to down, so you can make it D. Or either you can represent this with 1 and 0 or this 1 and 0. That doesn't matter. Now, so after doing this, what you can do? What you can do? So basically, if you are at current index is 1, then you can check if it's R, then you can directly move to down. Okay, you can directly move to down. And if it is D, which is basically if you are coming from down, like from up to down, so you can directly move to, like in this case you need to move down, and in this case you need to move right. And if this is not 1, this is the thing where when it is 1, if it is 1, if grade of row comma column is 1, okay, this thing is valid in that case. In case if grade of row comma column is equal to 0, in that case you can directly return something like this, okay, move right plus move left. So just in case you are familiar with DP, you will be able to understand this thing what I'm talking about. And you can try out this part. So this part is pretty simple, but this part is you can take hint from here and try to implement this. Now let's talk about the approach of this question. So how to solve problems of this kind. So just to make question little easier, what I have done, I have removed all the ones. So we will ignoring these ones for some time. We will definitely come to this. But for now, let's try to understand how to solve this kind of problems. If you are new to recursion or DP, so how to like approach this problem. Okay. So first of all, what I can do at current index, let's say I am at this index 0 comma 0. What I can do, I know one thing for sure, that either I can move to right or I can move to down. Okay, so let me try both of the things. So I will try to move right, I will try to move down. Okay, for now I'm just focusing on this part, right part. On this index also I will be able to move to right. Okay, from this index also I will be able to move to right. But as soon as I reached here, this is basically an invalid path. This is telling me that's invalid path. So as soon as I reach to the invalid path, I can definitely discard it. I will discard it. Okay. So I have a counter variable also which will be initialized to 0 initially. Superb. So as soon as I reach something invalid path, I will discard this path. Okay. So from here, I can move to down as well, right? I have tried moving right, which is invalid path, so I will discard this part. But this path is valid, so I will move to down. Okay, let me try. From this, I will try to move right, which is invalid. I will discard it, but I can move to the down. Okay, but this time I have reached my final destination. As soon as I am able to reach the final destination, I will increment my counter. So what I did here, basically from the first index, I tried approaching the right index and down index. From this index, I tried approaching this index. From this node, I tried approaching right, I tried approaching down. From every index, I need to approach either right, either down, right, down, right, down, right, down. Okay. So can you see a similar pattern on every index? On every index, I need to either move to right, either move to down. So can I solve this using recursion? Yes, definitely I can. Because in recursion, what we did, so whenever we try to calculate something repetitive manner, we can definitely use recursion in those cases. So how I will apply recursion here? So I'm index at my current index is 0 comma 0. Okay. So from 0 comma 0, I can move to 0 comma 1, right? And I can move to 1 comma 0, right? From this 0 comma 1, if I am able to write recursion for this 0 comma 0, and I can easily able to move to right and down, then recursion will take care of this. So if let's say for example what I am saying here, if I am here, I am able to write recursion for this index, for 0th index. If I am able to write recursion, recursion will take care to move from all this. Okay, but recursion will take care from here also I need to move here. From here I also need to move right and down. From here also I need to move right and down. Recursion will take care of every index if I am able to write for this index. We'll quickly see in next segment, in the pseudocode segment, how we will write recursion for this. Okay, so first thing is, if I am able to write recursion for this, I will be able to, recursion will take care of all these things. Second thing, I need to handle the edge cases like this. Let's say if I'm going out of bound either from the row side, either from the column side, or from the row side, or from the row side. Okay, either from here, either from here. In any case, I need to discard that path. So I can directly return a 0 in. So that will be able to help me not go beyond the array. Super. And the third thing, which is basically our answer calculating, as soon as I am able to reach the last index, I can definitely increment my counter. So what all paths will be able to reach the last index, I will be able to uh, increment my counter. Okay, so this with this way we'll be easily able to implement the recursion, which will start from here, and what all paths will be going here. I can increment my counter. Now, let's talk about this. I hope this thing is clear. Okay, we can try run for one more thing if you have any doubt. So if from here, I have completed this path. Okay, so from this right wala part is done. Now I will try to move from down. Okay, at this index, what I can do, I can either move right, I can either move down. Let's focus on right part. So from this node, I can either move right, either I can move down. Right part is discarded because it is invalid, but down part is able to reach me here, so I can increment my counter. Super. Now right path is done. I will try to move down. Okay, from this I can move to right, I can move to down. Down part is discarded because it is invalid, but right part we are able to reach the final destination. I can increment my counter. Similarly, we have some paths from here, we have paths from here, we have a lot of paths. Okay, so I hope that is clear. Now in this one case, what we do, so it's not very tough to handle, it's easy to handle. So we can have a condition like this. In case if grid is equal to, if grade of row comma column equal to 0, do I need to do anything? No, I don't, because we can see here, if grade is 0, we are able to just move right or left, or I mean right or down, and we are able to explore the path. But in case of 1, we have to do some special things. That special thing is, I need to just track whether I'm coming from right or I'm coming from down. If I'm able to uh, if I'm able to know in this index, so I can write something like this. So in this case, my approach will be simple. Okay, simple code, simple. Okay, but else, let's say if grade of 0 comma 1, I mean row comma column is equal to 1, in that case what I need to do, I need to track whether coming from right or down. Okay, so let's say if coming from right, in that case what I need to do, jump to down. No matter what, no matter down is invalid or whatever, jump to down directly. Else, so if I'm not coming from right, that means I will be coming from down. So what I need to do, I need to jump to right. No matter what, directly jump to right. Okay, and obviously in recursion we will handle those cases. Okay, if index go out of bound from this indexes, like from this indices, if I go out of bound here in this cases, this part, so I will definitely return a 0. And one more thing, okay, if as soon as we reach here, we will increment our counter. Okay, so I hope we are good to go with the pseudocode. Let's try to run the right pseudocode for this now. So let's start. So what I can write, I can write a function. You can name it anything. So I can write name row, column, and last move. Okay, whatever my last move, whether it will be, so right will be represented as 1 and down will be represented as 0. Okay, so how I will be calling the recursion. So my answer will look like something. I will start from 0, comma 0 definitely, and last move will be no matter, I can mention 0 here, 1 here, no matter whatever it is, because this 0, comma 0 index will always be 1. We can see here, okay, and last index will also 0, comma 0 index will always be 0, and last index will always be 0. So I don't need to worry about it. I can mention 0 here, 1 here, no matter what. Super. Now what I need to do in this case? If I am able to reach row equal to n minus 1 and column equal to m minus 1, okay, where n minus 1 and m minus 1 are my last indices. So what I can do? I can directly return a 1. Definitely I can return a 1. Okay, so if we talk about index, recursion, let's say this is my first index and this is my last index. So in that case, how many paths I'm having? I'm having one path to reach this, which is let's just start from here and I'm able to reach it. So that is the thing, right? Now next condition. So if not, okay, I'm mentioning not here. If not 0 less than equal to row less than n. What does that mean? If this means that my row is, this condition means that my row is in range 0 to n minus 1, but not, I am using not. So if this condition is not present, or not of 0 comma less than equal to column less than m, what does that mean? This condition means my column, this is for row, this is for column in range 0 to m minus 1. If this is valid, this is valid range, okay, and if this valid range is not there, then I can return a 0 directly. Okay, if you have any doubts in this part, just let me know. This is just simple. If you try to write the condition for, like, if row is in range, and I'm using not condition so that I can check for invalid indices. Super, super. What I need to do now? I need to check if grade grid of row comma column equal to 0. Then what I need to do? I need to either move right, either move down, and I will be calculating my answer. So I can return function of row plus 1, which is basically down movement, and my movement will be, I think down, for down we will be presenting as 0, right, and for right we are representing as 1. So I am moving down row plus 1, that means I'm moving down, plus function of r and c plus 1, which means I'm moving right, okay, and for right movement I am mentioning 1 here. Super. Okay, so I can directly return this, or I can store an answer. I can directly return this also, no issue. And in case if this is 1, in case that number is 1, what I need to do? I need to check if last move. Okay, this is basically last move. If last move equal to 1, that means I am coming from right. Directly go to left. Directly go to down. Not left. Directly go to down. No matter what. So return function of, I think, r plus 1 comma c, and this time I'm taking what move? I'm taking down move, right? So I will mentioning 0 here. Else, so that means I'm coming from down, so I will have to move to right. So no matter what, I will be moving to right, c plus 1, and this time I can mention 1 here because I'm going right. Super. So I think this code is pretty much done. We haven't memorized it yet, but let's try to submit this recursive code first. Then we'll see how, like, what is the repetitive thing and how we can memorize this thing. So let's try to code this recursive code first and check whether it is working fine or not. So I can write something like this: n equal to length of grid, which is my grid length, row count, m will be length of grid comma 0, that will be giving me column count. Now first of all, I can define a function which takes 3 parameters: row count, row column, and last move. Superb. I will be writing this code shortly. I can start from 0, 0, and last move I can mention anything that doesn't matter for now, because 0, 0 will always be 0. No matter what, I can write this, because I will not be checking this condition. I will be checking this condition only when my grid. So when I am accessing last move, I am accessing last move when my grade is not equal to 0. Okay, that's why. So when my grade is equal to 0, when my grade cell will be always equal to 0, so I will not be taking care of this thing, whatever it is. Okay, super. If row equal to n minus 1 and column equal to m minus 1, that means I'm able to reach my destination. I can actually return a 1. Super. Just in case I'm not in the correct range. So in that case, or not of 0 equal to less column less than m, I can return a 0. That means I went out of bounds. So I have to return. Now, if grid of row and column equal to 0, that means my answer is simple. What I can return? I can return either I can move right. Okay, that this means down. So row plus 1 means down. Column will be same, and last move will be down. So that means 0. Superb. Let me type here as well. So 0 means down. Okay, going down, and 1 means going right. Going right, coming from right, same thing. Okay, super. So this thing plus function of row will be same. This time I'm going right. Okay, so call, and for right I need to use 1. Super, super. Now, just in case this is not the thing, just in case my grade is not 0, grade row column is not 0. That means I can either move to, I can directly jump to right, I can directly jump to down or right. Okay, so I need to check if last move equal to 0. That means 0 means I'm coming from down. So what I need to, I need to directly jump to the right. Okay, function of row will be same, column plus 1, and I'm moving to right, so I can mention a 1 here. Super. Otherwise, that means I'm coming from right. If I'm coming from right, I need to move to down. So down, column will be same, and I'm going down. I'm going down. Okay, super. Now I think we are pretty good. Let's try to run this and check whether it is working fine or not. In getting some runtime error, recursive depth exceeded. Okay, one thing I forgot here is putting a plus 1 here. Okay, so things looks fine. Now let's try to run this. Okay, it is working fine. But if I submit this, let's try to submit this. I will definitely get a TLE because the time complexity is exponential for this question, because we are using recursion, we are keep counting for same cell, we are keep counting same thing. So let's see how we can memorize this. But let's try to, okay, we are getting a time limit exceeded. Okay, so let's see in the explanation. Let's try to understand, okay, how we can basically memoization. What is the need of memoization here? So I have drawn this thing. Now I will ask you one thing. How many paths from this node are there? So I can say one path is this. Okay, this is one path, which is like if I go right, I can immediately jump to the down. This is one path. Okay, one path. This is the another path. This is another path. So I'm having one more path. From this node, I'm having two paths. Okay, can I say this? From 1 comma 1 node, I'm having two paths. Superb. Now, how many times I'm reaching this node? Let's see. So one time I'm reaching like this. Okay. Second time I think I'm reaching like this. So I'm reaching this node two times. In case of large grids, in case of, let's say, you are having lot of numbers. So if let's say some node is here, so you will be reaching lot of times like this. Like if you have a lot of nodes here, so you will be reaching like this. Then this lot of paths. You lot of times you will be reaching this. And every time you're reaching this, you will be going to the last index with the different path. You are calculating the same count. So if I'm reaching from here, okay, if I'm using this path, I'm reaching this node, will the count from this node to this node change? What I'm asking is basically from this node to this node, how many paths are there? I think two paths are there, right? If I try to reach this node from this path, will this change? Will this two change? No. If I try to reach from this to this, will this two change? Two is what? Two is number of paths from this to this, right? Will this change? No, this will not change. This will not change. So you know what I need to ideally calculate? I just need to calculate how many ways I can reach from this to this node. And if I store path, okay, if I store like at this index, if I store how many ways I can reach from this to this node, then I can directly I can directly sum up these things, right? How many ways I can reach to this plus how many ways I can reach to this. Okay, so if I take a summation of this, I will be able to get my answer, right? So in case, let's see like this is my path 1, this is my path 2. Okay, so this path can go like this also, this path can go like this also. So I'm having total of 4 paths. So this node can be reached in 2 paths, and from this to this I'm able to reach 2 paths. If I sum up both, I can get my 4 answer. That's what we are doing here as well. Here what we are doing, we're just summing up. So if I'm more exclusively, if I'm more perfectly right this thing, so this is move down, okay, move down equal to this, move right equal to this. I can say like this. And in the last, what I'm doing, I'm just summing this up, move down plus move right. So I'm just here trying to explain you, okay, what is a repetitive path. So for this path, I'm just trying to calculate things repeatedly. So what I can do, if I'm able to memorize this, if I'm able to store this thing somewhere in maybe dictionary, maybe array, in a nested array, that means that can help. And I have something like this also. What is my third parameter? Third parameter is last move, which is either be 0 or either it will be 1. So I can maintain a dictionary, I can maintain a third parameter for that as well. So if you are familiar with DP, that will be very easy for you. Otherwise, you can practice some similar questions of DP first, then you will try to approach this memorization part. So I can definitely define a DP here. I will be initially initializing all the values from the 0, and the first the last column of the DP will be of 2, either it will be 0, either it will be 1. And rest all columns can have like this part, the second part will be of m length, and the first part will be of n length. If you are not able to understand this part, so I will highly recommend you to learn some DP concepts, then you can definitely able to understand what we are exactly doing here. Now I can something like this: if DP of row call last move is not equal to -1, that means I have already calculated this index. So I can directly return this, right? I can directly return this. Super. Otherwise, I need to make little modification. So I will be initializing answer as 0. I will be making answer equal to like this. Answer equal to like this. Answer equal to like this. I haven't done anything. I am just returning answer here. Okay, I have removed return statements from here, and I'm returning in the last. And before returning the very important step, I will put it. Okay, please DP of DP array, please store this thing. So what I'm doing, I'm just storing how many ways I can reach from this to this, if I'm able to know this. So whenever from this path, if I'm going, so but as soon as I reached here, I know the answer. Okay, what is the answer? So I will be directly returning. I will not be moving ahead and calculating. I will directly return, okay, hey 0, please listen, this is 2, this is 2, hey 0, from here also I have two ways. Okay, so something like that we are doing. I hope you understand. You can comment down your doubts. So code looks good. Let's try to run this. Okay, it is working fine. Let's try to submit this and see whether it is working fine or not. The video became little long. Okay. Very important step. Very important step. I need to keep modulo. Okay. So while summing up, I can doing modulo. I can do modulo here. So I can define a mod here. Uh, 10 to the power 9 plus 7. And every time I need to do a mod here. And okay, rest assured. Let's try to use this test case as well. Okay, this time it worked fine. Let me try to submit now. So we have given an instruction that the sum can be very large, so I need to return it modulo 10 to the power 9 plus 7. So yeah, this time it worked fine. I hope I am able to explain you this DP problem with recursion and why we are doing memoization, why we are able to solve this using recursion, the repetitive steps especially. So I hope I am able to explain you. Just in case you understood the problem, please make sure you give a thumbs up, and please subscribe to channel. It's a easy thing for you, but it takes a lot of efforts to me to explain this thing in this much details by running all these things and explaining all things very clearly. So thank you very much guys for watching this video, and we'll meet in the next question. Thank you.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us.